Hey guys, in this video I'd like to demo my Game of Life simulation. To give some brief context on what the Game of Life is it's a cellular automaton devised by John Conway that is governed by a few simple rules. The game takes place on a 2D plane in which cells are individually placed into an initial state. Once configured, the game no longer needs any input, and the evolution is based on this initial seed. Evolution is conducted by the following rules. Any live cell with fewer than 2 live neighbors dies as by underpopulation. Any live cell with 2 or 3 live neighbors lives on to the next generation. Any live cell with 3 live neighbors dies as by overpopulation. And any dead cell with exactly 3 live neighbors becomes a live cell as by reproduction. What's rather remarkable about the Game of Life is that great complexity can arise out of a very simple set of fundamental rules. So yeah, with that intro out of the way, I'll go ahead and demo my program. Okay, so before I hop into demoing the code, if you're at all interested in running this program yourself, feel free to go ahead and check out my GitHub. There I have a README that contains steps on how to run it with some instructions. Okay, so to run the code, simply just fire up the game script. Upon this, you'll be prompted on whether or not you would like to use a pre-existing formation or if you would like to manually configure your own. For demo purposes, I'll start by manually configuring my own formation. So once you type in N, it'll take a couple seconds to launch the Pygame UI, which is this. Okay, so here is the 2D plane where each individual square that you see here represents a cell. Right now all the cells are dead. If we go ahead and click on a cell, it becomes alive, represented by this blue box. So to begin, I just want to show some possible different types of formations that are common within the Game of Life. The first is known as a stable formation. This basically means that in between iterations, given the rules, the formation is initiated such that nothing changes. So we can go ahead and hit enter to run the simulation. And as you can see, the formation stays stable. There's no changing within it. So that's a rather boring example, but this comes into play on how to make larger simulations that breed more complexity. But let's go ahead now and check out an oscillating formation. By oscillating, all that means is that it basically oscillates between 2 periods in which the formation can exist between 2 different states, and it continually goes back and forth, similar to like a sine function. So one of the most famous oscillating functions is just simply 3 cells in a row. So if we hit enter, you can see that given the rules, the cells oscillate between a horizontal line and a vertical line. Alright, so we go ahead and reset it again. So now I'm going to show you a spaceship formation, and this is starting to get into the more interesting types of formations you can make. Okay, so now I'll go ahead and demo the spaceship formation. So you can go ahead and it's 3 down, 1 to the left, and then 1 up, like this. And you can now see we have a formation that's able to stably glide across the screen in perpetuity. If the game plane extended beyond this little box that I have here for my window, given the rules, this formation would last forever. So it's stable in the sense that it's permanent, but it's able to move and glide. So now that we've checked out some manual formations and we have a better idea of how the Game of Life works, I'd like to go ahead and show a rather complex formation that I have as one of the pre-configured ones. So if we go ahead and run the game script again, and this time load in a formation, I'd like to demonstrate the glider gun. This is a formation that's able to infinitely create new cell structures and It's actually rather rare that formations are able to do this. There's only a couple known ones. That might have changed, but for a long time there were only a couple known formations that were able to infinitely increase the number of cells in the total game. Um, so let's go ahead and just run it, and you can see how this works. So this structure basically has this oscillating main function, and then these two stable blocks that it bounces in between. And for every collision here, you can see it creates a collider. And because of this, because it creates a collider in this sense, it's able to forever increase the number of alive cells. So if the screen didn't end here, the number of cells could, go on forever. So this is actually a really interesting formation in the Game of Life. So finally, I'd like to just briefly demo some random configurations. So if we go ahead and run the game again, and let's go ahead and manually input a formation. From my own experience, and I think this is obviously anecdotal, I haven't played with this enough, but from my own experience, the vast majority of configurations will most likely result or it will converge into a stable formation, such that there will be some existing part of the cell left, but the majority of the cell will die. So if we go ahead and just click through, let's say we do something like this. This looks good, and we go ahead and run it. We can see, just like that, the cell, the formation has converged into this stable body. Now, I don't know if this is always the case, but this is, from my own testing, this seems to be mostly the case, where it will converge down to some stable and oscillating blocks. So yeah, this was my implementation of the Game of Life using Pygame. Once again, if you'd like to check it out, I'll be linking my GitHub in the description down below.